Welcome back. We hope you enjoyed the break and you got lots of water in you just to rehydrate your body. So at this point, we're going to pass it over to a workshop. For everyone who has a circuit playground, if you can get your hands on it just to get ready for this, and make sure you have your kit by your side. If not, not a problem. But I'm going to pass it over to Lucy.
Hiya, my name's Lucy. I'm a software engineer at Queen's University Belfast, and I'm the treasurer of the Northern Ireland Raspberry Jam. Part of my role at the Jam is to help create new workshops, and this is a workshop that we created specifically for the Northern Ireland Dev Conference, but it's similar to a lot of workshops that we've run before. So if everyone has their kit in front of them, the important thing we're going to need to make sure that you have is your batteries are in your holder the right way up, and that you have everything that you're going to need before you get started. So today we'll be using the Circuit Playground, which is a board that has been developed specifically for young people to learn, or any people, to learn how to program and how to make code work with electronics and stuff. So the first thing that I'm going to show you how to do is to wire up your Circuit Playground and how to take it away from your computer as well, so that it's wired away from your computer. And then I'll show you how you can access MakeCode and then get started programming. So the first thing that we have is our Circuit Playground board has two sides to it. One is a micro USB and one is a JST port, which is typically just used for battery packs and stuff. So in order to get the code onto the Circuit Playground once you have it done, you need to take your USB cable and plug the smaller end into the micro USB port and the larger end into your computer once we're ready for that step. And then whenever you need to take your Circuit Playground away from your computer, you then plug the battery pack into the other side, and it should show up a ring of red lights once you turn it on to show that it's on, and then it'll show whatever code you already have on it, which I already have code on this one. The Circuit Playground's a really easy board to use. We love using it at the Jam because it's got so many features on it. It's got so many sensors and outputs that it can make. So it has a speaker as well as the 10 LEDs, which are called neopixels whenever they're made by Adafruit. The neopixels are programmable, which means we can tell each one of the neopixels a different color to be, and it can handle that by itself. And they're also RGB, which means they can take on any color that you can imagine because they use a mixture of red, green, and blue light. That's why sometimes you hear people call it like an RGB keyboard. They mean that the lights in it are RGB, and that's where RGB comes from. So once you're familiar with all of your digital kit, all of your physical kit that you need to use, we're going to go over to our browser. So I have the instructions open just on another screen. You'll all have instructions at home, but for people who didn't receive the kit, these are our instructions as well. I think they'll be available on the website afterwards if you already have this kit or if you just want to get started with it at home. And we're going to go to MakeCode, if I can type, adafruit.com, and it should show up this screen. And obviously I have some projects that I've already worked on, but you will need to click on New Project, and it shall open a screen like this. So if any of you have programmed in school, typically primary schools and junior years or secondary schools will program using Scratch or App Inventor, which is a block-based programming language, and it means that you drag and drop all of your components into where you need them to be. So I'm just going to make this bigger. So this is what you'll probably see on your screen, and you can see that it starts off with one block, but all of the blocks are in here. So it's important to take some time to familiarize yourself with the blocks that you're looking at and what aspects of code you need, because each of these will send an instruction to the Circuit Playground, and it's important to be familiar with where you're looking for different aspects of your code. But I think that MakeCode is really good for learning how to figure out where to get those different aspects. So one of the first things that we're going to use today, if I just go back to my instructions, we're going to try dragging out one of the input blocks so that whenever we have an input to our physical Circuit Playground, then we can program it to do something whenever that input is accepted. So for that, you go into input and you drag out this block, which is on light dark. So the point of this workshop today is we're going to make a nightlight. Should have clarified that. So that in the darker hours it turns on, and in the lighter hours it turns off. Obviously we're in a studio today, so I'll just simulate darkness however I can. But the point of the nightlight is we want it to be off whenever it's bright and on whenever it's dark. And how we can do that is pull out this block, and this block is a direct representation of what your circuit playground is. And you can see that whenever you have some code into your workspace, it'll show up on the left-hand side in the emulated circuit playground. So this emulated circuit playground is a really good way of testing your code before you actually put it onto your board. And whenever you use the light sensor, you can see that you have to scroll up and down this little circle to modify the light levels. So whenever it's really dark, it'll turn on, and whenever it's really bright, it should turn off. Oh, I haven't given it anything to do whenever it's really bright, that's why. So I can also pull out another one, and whenever you see a drop-down tab in any of these blocks, you can click on it, and it will drop down all of the options that you can be given. So the other option other than dark is obviously bright, and then whenever we want it to be off, we can select the grey in the center of the circuit playground diagram, and that will just blank out all of your lights. And this is a bit tedious, but there we go. So we essentially have a working nightlight at this point. So whenever it's dark, the lights go red, and whenever it's bright, the lights turn off. And you can see that emulated in your circuit playground over to the side. So the next step now is we have all of this code written. So this is what your code should look like, and this is what mine does look like. The next thing that we want to do is download the code. Now, I'm quite good at writing instructions, but I'm not very good at checking that they work. So the instructions that I've written on the worksheet aren't exactly right because the software inside the circuit playground has changed in the past month since I wrote the worksheet. So what we're going to do is plug in our circuit playground into our computer the way that we talked about earlier. So micro USB into the silver port, and then bigger USB into any USB port on your computer. And there are a couple of ways that you can download onto your computer. So obviously that's bringing it up because it's recognizing that there's a device plugged into the computer, but I don't need that right now. What I can do is, if you're on some browsers, so I know it definitely works on Chrome, but some other browsers, you might be able to go into the cog at the top right and go to pair device. And my computer generally already knows it's there because I do it so much. And then you're looking for CPlay Express, which is what your Circuit Playground is. It's a Circuit Playground Express developer board. And you want to just pair your device to your computer so that they can talk to each other and you don't have to look in the file system to find your device. And what should happen is you click download and it should, yeah, so that's right. So if I turn it over so that it gets dark, you can see that, ignore that error message, so that doesn't mean anything. Whenever it gets dark, you can see that the lights come on, and whenever it's much brighter, I can probably hold it up to that light. Yeah, the lights go off. So you've got all your code written and downloaded to your circuit playground. The other way that you can go about doing it, so I'm just going to change the colors so that you can see that I've downloaded new code. So I'm just going to change all the colors to pink, and then I'll show you the longer way of downloading code because sometimes some browsers don't support it, and I'd like it if you were able to also join in if you didn't have the right kind of browser. So we won't pair it this time, but I'll just make sure it's not paired. No, I want to unpair it. So instead, what you can sometimes do is click download, and it should download it to your browser. And then you'll move the downloaded file. Yeah, so you want to click on this button, Circuit Playground Untitled, because I haven't given a name to our project yet, because I was going to do that in a minute. So once you download the actual file, it should show up in the bottom of your browser, down at the bottom left, where downloads normally show up. And then you're going to go into your File Explorer, and go into downloads, and then you want to move. So if you're all the lights on your Circuit Playground are off, what you need to do then is click the button until they're all on. In the worksheet I said until they're all off, but I meant all on. So it needs to have all the green lights on it to show that it's in programming mode. And then that way we can drag this new file that we've just created into here, into our folder, and it should, if I make it dark, so it's gone pink. So that's a slightly more complicated and longer way of downloading stuff onto your Circuit Playground. That's why they built the pairing device ability, so that you're able to do it really quickly and easily. For the rest of this, I'm going to use the pairing device way, but if you have any struggles with it, yeah, I've just been texted. If you have any questions, pop them into the chat, and then they'll be sent to me, and I'll be able to show you how to do it again, just if you get stuck with it. So the next part is, yeah, so we've downloaded it all. The next part is there are some challenges that we could work on to make our code more complicated than this. So far, we do have a working nightlight. It goes dark, or it goes off whenever it's bright outside, and it goes on whenever it's dark outside. So I've written 3 challenges that are of varying levels of difficulty. If you have the physical printed out version of this, the challenge will be at the bottom of the page, and then the solution will be at the top of the next page so that you don't accidentally see it. But it discusses if and else blocks, as well as how to change the brightness between 0 and 255, and I'll discuss in a minute why that number is important. And then also how to use an array, because I figured I should cater it to all abilities. But the next step, if you want to keep working on the code side of it, that's great. But the next step that I'm going to do is I'm going to work on the housing that we've designed. So at the NI Raspberry Jam, we pride ourselves in being able to have a bit of fun with electronics, but then also integrate some creative stuff with it. Not everything has to be about computers and on computers. You can do a lot of like non-screen time that will still be very rewarding and still like add to your project. Because this is a great nightlight, but it would look a lot better if it had a casing. So I'm just gonna cut this out, proper Blue Peter style. Oh, in true Blue Peter fashion, I do actually have some that I made earlier, if the lights would come on. So you can see I've put a rainbow light on that, and then you just slot that over the top, and you can see whenever it's in a dark room, it glows out nicely. Kaylin, do we have any questions yet? I haven't been texted yet. Yeah, so at the Jam we do a lot of sort of making stuff, and we would do a lot of cutting and sticking because we like integrating our electronics projects into other projects. So a good example of that we have at the Jam that we run regularly is the microbit milk monsters. So a Circuit Playground is very similar to a microbit in that you can have a lot of inputs and different outputs with the microbit, but the Circuit Playground just has lights on it which are much brighter, and you can change the colors and stuff, so it's why I like using it. But the microbit is great for integrating with like motors and stuff and servos. So a servo is a motor that can turn in both directions, and we use that at the Jam to create these milk monsters out of old-fashioned like milk cartons or orange juice cartons, like the Tetra Pak ones that we cut the teeth out of, and then we install a servo so that the mouth opens and closes. And it's a great way to get kids to learn without realizing that they're actually doing some learning. Because in that they'd have to figure out directions of rotation and stuff. But with this project, we just have nice, easy, simple lights. So I designed this this casing based on the casing that we have for a similar workshop, which is the microbit nightlight. It was designed like a little house, and I decided that I wanted our Circuit Playground design to be like a spaceship because I was watching Apollo documentaries, so that's where that came from. And I decided to make it, I'm not even cutting that. I decided to make it based on a pentagon because it just looked a lot cooler and it was a bit more complicated. And I like showing the process of whenever I make stuff, how I design it. So the first one started off like this. It was just, I think we've got the top-down camera. It was just a piece of scrap paper that I had that I drew out all the shapes that I knew I needed, and I worked out the angles of the triangles and stuff so that it would all meet in the middle, and I just taped it up. And then after that, I took all those measurements and put them into Fusion 360, which is a CAD program, so that I could have a very accurate layout of the template. And then I put that into Autodesk Sketchbook and drew the spaceship design on it with all the windows and the bolts and the little space person inside, a little astronaut or cosmonaut. I have to cut this out very carefully so that it'll stick together in the right way. Keelan's telling me you have no questions yet, so you must all be flying. Everyone's got an array in theirs now. Everyone knows exactly what an array list is. So as I spoke about, the first challenge uses an if-then-else block, which is really good for understanding how computers make decisions. And a lot of people always tell me programming using blocks isn't really programming, which I always disagree with, because the point of it isn't to actually write loads and loads of code, but it's to understand what each component does, and having it separated into the blocks like you're using today really helps you figure out what each component does and why you're using it, and why it's why the if and then has to go with the else, and why that helps the computer make decisions. My computer's about to turn off. And also a great thing in MakeCode is, if you're at all familiar with JavaScript, which I can't claim that I am, there is also a JavaScript translator which turns all the code into, it turns all your blocks into real JavaScript, which is just an interesting way of learning JavaScript. One of the people that runs the Northern Ireland Raspberry Jam, Andrew Mulholland, he's our chairperson, he helped make that feature, and he said he's very proud of it. Sam's nodding at me. So the first challenge is, can you implement the same thing using an if-then-else block instead of using the on-light or on-dark blocks? The second challenge is, how can you modify it so that you get to decide what the threshold of brightness and darkness is? And that requires an understanding of how light is measured by computers. So computers use a lot of binary. So yeah, that took me a while, but I got that cut out. And the next step, just while I interrupt my own binary talk, the next step is to fold along all of the dashed lines, and that includes all the ones up here. It's a bit easier if you have a ruler to do this, because you can fold it over the ruler and then do that. But I'm just going to do it by hand. So the second challenge is about brightness, and that means you need to understand how computers think about brightness and how they store brightness. Because obviously I could come into the studio today and be like, well, this part of the studio is quite bright, but that part's quite dark. So we have to put a numerical value on that. And computers use a lot of binary because it's an easy way for them to store things, because it can either be 0 or 1, or on or off, or yes or no. So binary means there's two states of something, and binary is base 2. And then if you put 2 to the power of 8, which is a byte, that's 256, which is why you'll see 256 or 128, which is 2 to the power 7, in a lot of different computer things, and especially in the second challenge. You'll see 255, because if you have 256 states and you include 0, that goes from 0 to 255, which is what brightness is measured in on circuit playgrounds, as well as, so that's the brightness that's coming in on the LDR, as well as the brightness that's coming out of the lights. That's also measured at 0 to 255. But that's just why computers use those numbers. The tricky part now about this template is getting all of these little folds exactly right so that your spaceship can look as space-worthy as possible. Otherwise, your astronaut will be all over the place. Okay, so there's 3 done. I think I'm just going to use tape today because it's a bit quicker and I don't have to hold it till it dries. But you can use tape or glue to put these together. You can also colour it in. But today I just decided to not. So you can see how once you've folded all those pieces together, you're starting to make the right sort of shape. So I always tape this side first. This is the long side because it's the easiest. And then I'll fiddle about with all the top bit in a minute. So take some tape. I'm just going to pop it on the inside so that it's hidden away. I'm going to put this flap on the inside of this and make sure that all of the lines line up so that all of our pieces of the spaceship work together. And just stick it like that. Oh, nice. They'll never hire me for Blue Peter now. What am I going to do? Okay, so we've got our first side done, and it's the same process, but with the 5 points, which does get a bit more fiddly. So I'll put some more tape on that, on the outside. So hold it all together. You can also use glue so that you can't see the tape, but it's a bit fiddlier. And then, once you have this, you can slide it over your... I'll show you how you can wrap the circuit playground in the battery so that it stays nice and compact. I didn't want to have to make a massive casing just so I could fit the circuit playground in. So you can see how if you manage to get those lined up really well, then it will just naturally form a point. And then just make sure the tape's really secure on the inside. Nice. I just have to do that 4 more times. Still no questions, Gillian? Is everyone doing okay with the programming bit? Has everyone got a functioning nightlight? Nice. This is better than it would have gone at a normal jump. I would have had loads of questions by now. Oh, my computer's gone. I think I explained it a bit better and I wrote better instructions. I normally don't write instructions for the jam because we've got so many great volunteers that can just jump in and explain things. But I figured, seeing as we have all of our students today working by themselves at home or with their parents at home, I would do a bit of a better job on the worksheet. So once we have all of the points together, this is so fiddly. Why did I design this? Who designed this? Okay, one more. This one's the hard one because you have to put 2 in at the same time. And then I will run you through the rest of the... Oh, I'm just going to stick on the outside. I can't be bothered. It's too fiddly. I'll run you through the rest of the coding challenges and sort of explain how you can use arrays and stuff, and how just because it's MakeCode and just because it looks very basic and it's got very bright colors doesn't mean that you can't use proper programming techniques and proper programming features. It is like a genuine thing that you're able to use, and you can use it in real life projects and it will work, and it's very like robust, and you can trust that your code is always going to do the right thing on the circuit playground. It's never going to fail you. So there's no reason to sort of feel better if you somehow write the code in words than in blocks. So once we've got our spaceship, mine's a little bit lopsided, but the spaceman seems very happy. We're gonna... Do we have a question? No compatible device found. Error when we try to pair. So that means you need to... If you're having the no compatible device error, is that whenever you get to this point? So this is the point where you've clicked the cog and you've clicked pair, and it's brought up a security thing being like, Adafruit would like to connect to your computer. I'm not getting any live feedback. Keelan's still asking questions. I think, so if I unplug it, does it say that error? Oh, you're getting this error, no compatible device is found. What you need to do, I think, because they change this a lot, which is why the instructions are wrong. What I think you need to do is have it on this mode. So whenever you need to press the very small center button until it goes red and then green really quick, and then you compare it. But the people who make Adafruit aren't the same people who make MakeCode, so sometimes they disagree about how this works. That's why it changes a lot, and that's why it's not right. So I think that should work once you've hit the center button until it goes green, because that means it's in programming mode, and that means that it's looking, or the computer is actively looking for it. I hope that helps. Kaelan will tell me in a minute if that helps. What I'm going to do now is show you how you can wrap up your circuit playground. So once you can unplug it from your micro USB, there's no power to this anymore, but the code is stored on it. It's a very small amount of storage so that you can store code on it. Everyone was saying yes, okay. That probably means it's sorted. You keep interrupting me talking about storage. It's got a very small amount of storage, so you can store just enough for one program, but it can't store loads of stuff. It basically just rewrites over the last program every time you upload one. So if you plug it into your battery pack, this is quite a big, chunky thing to try and fit under our little casing. So I always wrap this part of the cable underneath the clothing hook. So this is a battery pack if you want to sew it into something or clip it onto something, which is really useful, and we should have used it in other projects, but we just bought these recently. So if you clip it under there and then set that directly on top, sometimes you can secure it with a piece of tape. This has Velcro on it for a different project, but if you secure it with some tape, then it won't move anywhere, or you can just hook it underneath this part of the cable. That means that you can set it down on the table, and it's basically going to always point upright, and your lights are always going to come out. And Sam keeps trying to show me your comments from so far away. He's tried to make the font really big so that it's under, so I can't tell. But yeah, so there we go. You slot your housing over the top of your circuit playground, and it works like that. Obviously, I'm in a very brightly lit studio. Thanks, that worked. Okay. I'm in a very brightly lit studio, so it's hard for me to simulate darkness and stuff so that it can go on and off. But yeah, if it's on, then that means it thinks it's dark, which is why I've written the further challenges. But you can play about with a torch. Generally, it works really well with a torch if you turn it on and off to like shine the light directly at the circuit playground, like at this space, because that's where it's detecting the light. But obviously, very bright lights, it's kind of confused, and also the light is reflecting off the white of the paper, so that's why I wrote the other challenges, so that you get to decide what your circuit playground thinks is brightness and darkness. So there you can see the second challenge was, now that you know brightness is measured on a scale from 0 to 255, how could you make the neopixels change brightness gradually as the light around you gets brighter and darker? And you can see the code is written there. And the code is basically, mine is showing the green light but still not connected. Hold it till it's green. No, you should just have to click it once. So it's so there's two big buttons, and then there's one very small reset button in the middle, and it should go red, and then, oh no, that's only if it's plugged into the computer. It has to be plugged into the computer first, that's why it's weird. It should go red and then green very quickly as the computer recognizes it. That's what it's saying. Yeah, so there is it off, and there is red and green very quick. So that's what you're looking for. Mine is showing green light, but still not connected. Have you tried, whenever you plug it in, does it pop up with the file explorer? Is the computer recognizing that your device is there in the file explorer? Because it might just be your browser isn't recognizing that it's there. Kaelan will get back to me on if that worked. Yeah, so the second challenge was, sometimes you don't want it to just come on and off, like black or white, and you want it to fade up and fade down. So I think we could probably do this code very quick. So what we're going to do is, on start, we need to set all the pixels to one color, And it's important that we differentiate between what you do on the start of your program. What do the big buttons do? Oh, the big buttons can be used as an input as well. So instead of having the light as an input, you can use sound. So you can do something if you clap your hands in front of it, you can make it do something on that loud sound. Yeah, it is like the microbit. It has two buttons on it like the microbit. And then you can press either the A button or the B button depending on what you want it to do. Me and Sam will cover that in the next 10 minutes after this whenever we talk about all sorts of microbits and Circuit Playground projects. But yeah, in this solution 2 code, if I can ever get through it, it's important to differentiate between what you do on the start of a program and what you do continually throughout the program. And that's what I was trying to get at with this piece of code. So on the start of your program, you want to set all the pixels to pink, but you don't want to change the color of all the pixels all the time, but you don't want to continuously reset them to pink because that would just be a waste of your Circuit Playground's computing power. And then what you want it to continuously do is measure the light level, which is the pink block in there, because that comes from the light part. Someone in chat. That comes from the pink block section, and then you want to put it in some purple blocks, which are from the maths section, or we would say maths, because then that's doing some calculations. So you can see how MakeCode looks really basic, and it is really bright colors, and it's rounded blocks and stuff, and it looks really, really simple. But you can do so much with it because it does have the aspect of like calculation and decision making, and you can implement arrays and you can set up variables and stuff. So just because we use it for the very basics doesn't mean that it in itself is only for basic things. You can really use it for anything. And we have a lot of projects that we've written in MakeCode that have gotten very complicated, and then we can go in and edit the JavaScript so that we can do some stuff that the blocks maybe can't do. But this worksheet will be uploaded, I think, to the website after this talk, which is ending shortly. And you'll be able to work away on the challenge 2 and challenge 3, which are the harder ones, which are designed more to test your like actual programming skills. But yeah, that's me. I've got a lovely wee nightlight now. Well, I've actually got 2. And I hope everyone has gotten through it and has been able to get it working. Someone has said that sometimes that issue of it not going green is an issue with the USB cable, which I have found, which is why we have so many USB cables at the jam. Sometimes it's just a dodgy connection, or we sent them out to you so we know that it's the right kind, but sometimes it can be the wrong kind of USB cable. We'll be here for a lot of the day, and you can keep putting questions in the chat if you're still working on this workshop in between now and the next workshop. And I hope to see lots of photos of nightlights tweeted at me and at the Raspberry Jam and at NIDC. I'm at astro_Lucy Bell on Twitter because I like to pretend I'm an astronaut. And we also have at NIRaspJam, RASPJAM. And then we also have NIDC and all those people. So make sure you send in loads of photos because I want to see them. I want to see the thing that I helped design in other people's hands, in other people's code. And I think me and Sam are now going to be talking about the wearables projects that we've worked on and how these sort of like workshops have come from those projects and how we've simplified the project into a workshop so that everyone can access it. And that's me.
So, welcome back. Hopefully you enjoyed the entire workshop and you got your rocket to finally light up with all the different kind of components put together in MakeCode and onto your Circuit Playground. Any issues, once again, fire them into Hop-in chat. We'll be on straight onto them to help fix them. So at this point, we're going to have a little bit of a discussion between myself and Lucy, and we're going to talk about some of the projects that have happened in the past. Specifically, there was one where we both attended a formal, Lucy's formal to be exact, and Andrew Mulholland, the genius that he is, had recommended that we put LEDs and integrate some sort of lighting into my suit, into her dress. So today she actually has the dress. I unfortunately could not get a hold of the hat, but it's got all sorts of computing elements to it. We're going to explain through what we did and actually what happened, and hopefully give you a bit of inspiration on what you can do in your own time. So
The unicorn horn has the wrong code on it.
Oh, okay.
Whatever.
So
So if everyone's probably wondering, why is she wearing a dress to a tech conference? What's that all about? Hopefully this should turn on. So as you can see, this was our formal dress, my formal dress, and Sam's formal hat. It doesn't read very well on a very bright studio. Do you want me to stand somewhere else? No? Oh, you're going to turn it off? Yeah. So it should be flickering and sparkling because Andrew very carefully wrote the code so that we weren't using too many of the lights at one time because there was issues with power. But this dress uses a microbit, whereas we were using Circuit Playgrounds a minute ago, and it uses 2 different power supplies. So it has one power supply for the microbit and one power supply for the lights, because the lights need a lot more power. And on the surface, it always seems to people like a really simple project. Put some lights in a dress, you look like a Christmas tree. But whenever you actually start working on it, you do have to do the calculations of how many volts and how much current do I need for these 10 lights, or 9 lights today because one broke, and how much of that do I need for the microbit. And if I power those 2 things off the same power supply, is that going to create a problem for the microbit, because the microbit can't handle that much electricity. So you do what looks like a very simple project does involve like trying to figure out the difference between parallel and series circuits, because me and Andrew argued for weeks about whether a NeoPixel was a parallel or series thing, because it had 3 different ports on it, so we couldn't figure it out. And then your hat also used a microbit, but in a slightly different way. So yours didn't sparkle, yours just created a rainbow. So I'll leave the dress on, but I'll sit down so that Sam can also have some time in the spotlight.
So thankfully, I actually do have a microbit on me. And so basically this small device with all its wee pins on the bottom, we're able to power and to control the actual chain and daisy chain of LEDs, which Lucy had put together, soldered and got working, and then Andrew helped diagnose any issues and help us out along the way. Whereas with the hat, far simpler, far simpler. Essentially, it had a battery in it, had a controller, and an LED strip. Pretty simple. So the LED strip was just like the one you use on the Circuit Playground. It had LEDs on it. You could just tell it, right, I want this color, and it lit up that color. And you could say, this set of LEDs, or these number of LEDs, I want you to light up this color, and set the other colors all independently. We've tried to go a bit simpler with the hat though. The actual LEDs only went rainbow, and it kind of faded across the top of the top hat, because you had a tall kind of surface that you could actually shine the light onto. Very, very nice kind of look. Although it was navy, you could still see the color coming through. Now, the battery was a bit of an issue. Unfortunately, it's not as easy to get a hold of the battery, and so that was the hardest part of it. But other than that, the microbit, we also tried out what's called an Adafruit Gemma, which is basically the size of a 2p coin, and it can tie into so many different wearable technology. You've got thread, which you can sew,
it's
and
like
you can
a
actually...
very small Circuit Playground.
So
I think it has fewer lights on it.
Oh yeah, no,
Yeah.
The thing is, the components though for it, it's all sewable thread, which should conduct electricity. And you had experience with the electricity?
Yes, I had experience with electricity. You might have noticed that the Circuit Playground has holes all the way around, and the pads, what we'll call electrical pads, are they're sort of gold because they can be used like a pin on a Raspberry Pi. So whenever you plug something into the GPIO of a Raspberry Pi, that is like a physical connection to something else, and you can do that with the pads on a Circuit Playground as well. You can either use crocodile clips, it's very crocodile clip friendly, we use that a lot at the Jam, or you can use conductive thread, which you can buy from Pi Moroni, which is a UK distributor of, this is for all the parents, is a UK distributor of Adafruit, who make all of these amazing components. And it's just thread which has a little bit of steel running through it so that you can wrap it around something really tight and you'll have a physical electrical connection between that thing, but it's still really flexible and you can still integrate it into clothes and stuff. We started using steel for this dress, or we started using steel thread for this dress, or conductive thread, which sometimes has silver as well. But it was too much steel thread, so you have to think about like the length that your electricity has to go over, because it can burn out the thread, whereas it can't burn out the copper, which we eventually used. But yeah, conductive sewing is really interesting, and it's a really great way to integrate electronics into much like lighter clothes, whereas a top hat is a very rigid thing, so you can just use real wires.
So that's where, with ours, all you had to do is poke a hole through the actual bottom of the hat and feed the wire through, and it went straight onto the hat, or straight into the LEDs. But other than that, the actual code side of it, a bit different. I know for Lucy, it was a make code interface.
Yeah, we used make code, which we use today. It's really simple to use, and it created the rainbow pattern that's on this dress. But you used...
So this is a bit different. Essentially, the program, the Gemma, you can either do it through the Arduino library, which is a bit finicky to work with, but works, it does. But the primary use was, or the primary way to program it was, I think we dropped an Arduino script onto it, just to kind of make sure we could work with the low-level kind of components of it. There are other ways to program it through graphical user interfaces, but we unfortunately we ended up using just the script and using C just to program it all together. So yeah.
So we turned all of these projects into workshops that we can run at the Jam, like the Nightlight, which is going to be a new one. But we also created these unicorn horns, which it's a circuit playground velcroed to a hat with a battery attached to the brim of the hat and a 3D printed unicorn horn on it. It currently has the Nightlight code on it because I forgot, which is why it's not lighting up. But using 3D printing means that we can have a whole different conversation with students at the Jam about different parts of technology that we're able to use to integrate with our electronics. The same way that we did a bit of arts and crafts to cut and stick the Nightlight casing, being able to show them how we drew that in a pirated version of SolidWorks and then redrew it in Fusion, and we printed them out on Andrew's Anet A8 3D printer, which he just has at home. It's a really good way of bringing technology that seems so futuristic to real life with younger students.
And the thing is, with 3D printing as well, it's like if you're missing a component, you just print it. Now, granted, it does take hours, but you can do quite a lot. There was workshops that took place in England at an event called MozFest, where you used the microbit to create a lockbox, and you had basically 2 parts to print. You had the lid and the case. You slot the microbit into the case and the lid goes on, and there's little pads on the case that will click in the buttons on this to say this is armed, so you can't unlock it or else an alarm will go off. Little things like that can be quite useful for doing stuff at home, but obviously this is equipment that you'll have to get your hands on. Everything is available online, and you can actually buy it through distributors like Pimoroni or Pi-Hut. Also do different components, including stuff like microbit, say Circuit Playground, and Raspberry Pi components. Also, with the Pi, you have options of hats. Now, hats are very different. Hats use the pins, or the GPIO pins on the top, which are very spiky. Make sure you don't poke them too much or they will hurt. And basically, you just plug a board straight on top of it, and you've just expanded the functionality and added so many more features to your Pi. You have things like the Explorer hat, which allows you to have touch capacitive pads you can touch on, or, as Lucy was saying, crocodile clips. And the crocodile clips can then lead to a piece of tinfoil. Or if you're really adventurous and also very, very aware of the social distancing guidelines, if you and someone else in your household wanted to high five, you could high five and you could run a piece of code. Very simply done, all through Scratch and all through the same interface that was explained by Lucy through using the Circuit Playground. Now, once again, they're all available online. We do also have other projects. The Pi uses boards as well, like the Explorer hat and all that, all going on, all online that you can get. But I think for now we have a couple of questions that came through. So I'm just waiting.
Oh, in Sam's ear. I was like, where's the question?
There is a, why am I here? Could you read it out? Could you say it again? Oh,
that's a good question. We tested it so much throughout the day. So I think I started at 9. Andrew was a student at Queen's, so he woke up at approximately 2 p.m., which was early for him. And he came over to my house and brought the dress because he had been fixing it the night before. And we were testing it so much throughout the day that we completely drained the batteries. But we didn't realize because we hadn't thought about it. And then when we got to the formal, we got in through the front door and basically sat down at the table. And I was like, the dress is off. And Sam was like, what are we going to do? Wait, I have another battery. So Sam just had another battery, which completely saved the evening. Because otherwise the dress would have been off for the entire formal and no one would have seen it.
But yeah, it's really important. Today I have like 20 spare batteries just in case this stopped happening or in case the circuit playground stopped happening, purely because of Sam's ingenuity to bring a spare battery pack.
The thing is as well, one thing that was kind of like the loophole in all this that Andrew kind of like, put in the terms and conditions of this was we had to show up the next day at the jam fully dressed. I was in my suit and top hat, and Lucy was in her dress, and we had to do our workshops, the general running about, and did help out volunteering in the dress and the suit. Now, obviously, I didn't wear the suit. No, I did wear the suit. I didn't wear the dress, and Lucy didn't wear the suit. But we did have our own things that we had to work with on the day and make sure, I didn't lose a jacket or something like that.
I think the hat survived the whole time. The dress has copper wire in it, so it basically pulled out whenever I was at the jam. So only the top 3 lights worked at the jam. But everyone got to see the lovely photos from the night before. And I managed to fix it again yesterday after it being in a cupboard for 2.5 years. I fixed it again yesterday so that all of them work again.
Little projects like that as well, we do kind of like very spontaneously. There's ones where I think it was a high altitude balloon was sent up, and there was photos and such taken that we show off in talks at the jam, and we just put on Twitter. So usually if you have any interest or you see projects that we do, give us a shout. We're happy to kind of go through, usually in talks at the jam, what actually happens and how we did them.
Does Keelan have another question? Because he's making faces at us. Overheating? No, because we thought very specifically about that. So this has copper wire in it that I've twisted like 4 times around itself. I made like 20 meters of this 4-ply copper wire so that it had enough of a thickness, because I was doing AS physics at the time, so I thought I knew everything about electricity. It had enough of a thickness so that the voltage and current that was going through it, that I calculated was going through it, wasn't going to burn it out. Whereas if we had used conductive thread, it would have burnt it out, and that's a common problem with a lot of other people's sewable projects because they use conductive thread that isn't thick enough.
Whereas in my case, my head was just very warm, and it just heated up, and then there was a bit of sweat on top of my head. And also, I didn't want the battery to have or fall on my head or anything or have overheated. So, but in general, it was kind of a case of mine was passively cold. It was just my head that was warm. But Lucy did have.
I did some maths about the overheating so that it didn't happen.
Everything was considered very carefully because she had a battery pack. We both had batteries. She had a battery pack. I had a raw battery, just to make sure we're all safe, and no one else in the formal was in any way, shape, or form going to get included in it. So yeah.
But yeah, it was a good project, and it led to a lot of the workshops that we now run at the jam. You can find out how to buy some of the components that we used, or find some of the what, Keelan?
One of the questions here is, what age of children can join?
Ooh. Anyone, 6 to 106. It's for the young and the young at heart. We do have some jam people that come that are younger than 6 because they're with their parents, obviously, and they get a lot out of it because they've been brought up in a sort of a household and a culture of technology, so they're much better at like getting stuck in with it right away. But if you want to get involved in it more throughout your time during lockdown, whenever we can't have as many jams or we can't have as many in-person events, we do have a lot of resources on niraspberryjam.com/NIDC, and then also we tweet a lot of resources all the time on @NIRaspJam on Twitter, because we love the jam as much as anyone who goes there loves it, because it's just as much fun for us. And we are kind of like glad that we got to do this today, because it is it's a lot of the same stuff, just without a huge audience, but getting the questions in means that we kind of get to feel that anyway. One last question. Running a workshop by yourself is like talking to yourself in the bathroom mirror. You completely forget that there's a camera there, and you just sort of get on with it, because running a workshop whenever you're in front of a class of 30 children, you're used to making eye contact and you're used to like checking that each person is individually okay. But I think being able to answer questions as they were brought in made it a lot more sort of connected. But you just sort of forget that the camera's there, and you're just chatting to yourself about the reason that 255 is an important number.
Okay, so just pass on. That's going to be, that's I think us finished with our talk, and kind of just going through the different kind of things that have happened project-wise. what we're going to do now is we're going to pass straight on into another break, and at this point, it's just going to be get rehydrated again, make sure you're all okay, have a couple biscuits once again, but we'll see you again very shortly.